Hello everyone. I welcome you all to my second lecture on uniform acceleration. In this lecture, I am going to teach you two problems on uniform acceleration. The first problem is, on turning a corner, a motorist rushing at 20 meter per second finds a child on the road 50 meter ahead. He instantly stops the engine and applies brakes so as to stop the car within 10 meter of the child. Calculate the retardation and time required to stop the car. Okay, first of all, what is meant by retardation is it is opposite to the acceleration. Acceleration increases the velocity, retardation decreases the velocity. So we will try to construct a simple line drawing. So this is the position of the motorist. So at this position, the velocity is 20 meter per second. So let us consider u is equal to 20 meter per second, since u is the initial velocity. So he finds a child on the road 50 meter ahead. So this is the position of the child and the distance is 50 meter. So he instantly stops the engine and applies brakes so as to stop the car within 10 meter of the child. So he stops the car before 10 meter. The car is brought to rest. So at this point the velocity is 0 meter per second. We know that the final velocity is v. So u is 20 meter per second and the v is 0 meter per second. So here the retardation is applied. So that is acceleration in the opposite direction. Now the overall distance is 50 and the car stops before 10 meter. So the s is 50 minus 10, it is 40 meters. So the traveling distance of the car is 40 meters. Okay, now we will go to the problem. So these are all the given data. We have to find out the retardation, that is to find the A, and the time taken to stop the car, it is t. Okay, so in this problem we have u, s and v. We have to find out the value of A. So go to the equations. We have u, s and v. So we can use the equation number 3, that is v square is equal to u square plus 2a s. The final velocity is 0. So it is 0 is equal to v is 20, it is 20 square plus 2 into a into the distance travelled by the car is 40. So if you solve this, you will get a is equal to minus 5 meter per second square. So always the retardation will be in the opposite direction. So that is why we got the negative sign. So because here we have reduced the velocity from 20 to 0, that is why it is called as retardation. Then the second one, it is time taken. So now we have u, then v, s and a, and now we have to calculate the value of t. So go to the equations. From the first equation we have u, v and a. We can find out the value of t. So write the first equation. V is equal to u plus at. The value of v is 0, u is 20 plus a is minus 5 into t. So if you solve this equation, finally you will get t is equal to 4 seconds. Okay, that's all. The second problem, a motor starts from rest and uniformly accelerated to a speed of 20 km per hour over a distance of 200 meter. Calculate the acceleration and the time taken. If further acceleration raises the speed to 50 km per hour in 8 seconds, find the acceleration and further distance moved. So here the problem is split into two parts. The first part is, so the car starts from rest and uniformly accelerated to a speed of 20 km per hour. So this is the starting point. So here the velocity is 0, and at this point, that is over a distance of 200 meter, at this distance the velocity is 20 kilometer per hour. So you can convert the kilometer per hour into meter per second. We know that it is 20 into 1000 divided by 3600. So you will get 5.56 meter per second. So at this point the velocity is 5.56 meter per second. Okay, so for this region we have to calculate the acceleration and the time taken. So consider this as first part. Then if further acceleration rises the speed to 50 km per hour in 8 seconds. Okay, so after this point we are applying additional acceleration. So that acceleration is rising the speed to 50 km per hour. So at this point the speed is 50 km per hour. Okay, so if you convert the 50 km per hour into meter per second, it is 13.89 meter per second. Okay, now the time taken to travel to this distance is 8 seconds. Okay, so now we will split the problem into two, that is the part 1. The initial velocity u is equal to 0. For the part 1, the final velocity is 5.56 meter per second and the distance s is equal to 200 meter. So we have to find out the value of the acceleration and the time taken. A and t we have to find out. Then part 2. So this is the part 2, and for part 2 the initial velocity is, so here this is the initial velocity. So in the part 2 the vehicle starts from here to here. So u is 5.56 meter per second. That is very important. The end point of the part 1 is the starting point of part 2, and the v is equal to the final velocity of part 2. It is 13.89 meter per second and the t is equal to 8 seconds, and we have to calculate the acceleration and the distance traveled. A and s we have to calculate. Okay, so first consider the part 1. Okay, so we have u, v and s. We have to calculate a. So go to the equations. We have u, b and s. We have to calculate a. So we can use the equation number 3. So that is v square is equal to u square plus 2a s. If you substitute the values, then v is 5.56. 5.56 is equal to u is 0 plus 2 into a into the s is 200. So if you solve this equation, you will get a is equal to 0.077 meter per second square. Okay, so we have calculated the a. Then t. So now we have u, v, s and a. We have to calculate the value of t. So if you use the first equation, that is v is equal to u plus at, we have u, v and a. So the only unknown value is t. So we can substitute the values. The v is 5.56 is equal to 0 plus the a we have already calculated. It is 0.077 into t. So if you solve this equation, you will get t is equal to 72 seconds. So this is for part 1. Then consider part 2. Okay, in the part 2 we have u, v and t. We have to calculate a. So if you use the first equation, that is v is equal to u plus at, the v is 13.89, then u is 5.56, a we have to calculate, then a into the t is given, it is 8 seconds into 8. Okay, so if you solve this equation, finally you will get a is equal to 1.043 meter per second square. Okay, fine. Then yes. So now we have u, v, t and a. We have to calculate the value of s. So we can use the second equation, that is s is equal to ut plus half at square. S is the only unknown value. So if we substitute the values, S is equal to U is 5.56 into 8 seconds plus half into A we have already calculated is 1.043 into 8 square. So if you solve this equation, finally you get S is equal to 77.8 meter. Okay, so the important point about this problem is we have to split the problem into two parts. At the first part, the vehicle moves from 0 to 5.56 meter per second. At the second part, further acceleration is increased, so the vehicle's velocity is increased from 5.56 to 13.89 meter per second. So the final velocity of part 1 will be the initial velocity of part 2. You can see that the final velocity of part 1 will be the initial velocity of part 2. Thank you.